This is my course project summary for Module 1, Machine Learning Foundations for Product Managers, ready for you to review. The project topic is to build a machine learning model which predicts the electrical energy output of a combined cycle power plant. We have a dataset available which we can use to train the model, and as input data we have temperature, ambient pressure, relative humidity, and exhaust vacuum. As output data, we have the actual electrical energy output observed. This is also the target variable we try to predict. Since we are trying to predict a target variable with a set of observations available to us as features, the type of machine learning can be typed as supervised learning. The following steps were taken in the project. As a data preparation, I investigated if there is a linear relationship between input and output data. I also split the data set available to us into training, validation, and test data in the allocation percentage of 60, 20, 20. Based on the insights from the data analysis, I selected models and features. For all three models eventually trained, I applied multiple linear regression as algorithm. Since this is a standard multiple linear regression, there are no hyperparameters set. To evaluate and interpret the model, mean squared error, R squared, and adjusted R were chosen as output metrics. The regression analysis shows that average temperature and exhaust vacuum has the highest correlation. Based on this analysis, the following three models were selected. Model A with features temperature, exhaust vacuum, and humidity. Model B features were temperature, exhaust vacuum, and ambient pressure. And Model C applying all four features as input data. Training the model, we see the following performance. All three models show a multiple R close to 1. There is also a very small difference for all three models between R square and adjusted R square, showing a low risk of overfitting. We can conclude that all three models have a good performance. We evaluated the performance using the validation dataset and afterwards the test set. The mean squared error of model A and C is almost of similar value. Since the mean squared error of model A and C are lower than that of model B, we can conclude that model A and C have a higher or more predictive power in terms of how well they fit the data than model B. We can actually exclude ambient pressure as a feature. This was the summary of my course project. Thank you in advance for reviewing my project course.